Hello everyone, welcome to this video. In this video, we'll be discussing about certain operating system concepts that has been given as an assignment for us for the course operating system, course coordinator, Dr. Shivan Koda GM. Firstly, I would like to introduce my teammates, that is Rajshekar, Rajesh and Akash and Agri. So, we had been provided with three options for our assignment, in which we opted for option one, that is to create a child and parent process that generates random numbers and sort it accordingly parallelly. So that firstly we would like to understand certain concepts for the code implementation and try to understand some terms that is used in our code. So we'll be discussing what and all we used in our code. Firstly, we will know what is. We will know what is the concepts used in this. So firstly, we will know what is process management. Process management in operating system is a core concept in that deals with the creation, scheduling, execution, and termination of processes. It ensures efficient use of system resources like CPU, memory, and input-output device while maintaining system stability, which is very much convenient in process management. So, what is a process? A process, the context of operating system, is a program in execution. It is an active entity that represents a running application, including the program's code, its current activity, and the resources it requires to execute. Next one is the implementation of the code. The parent and child process often communicate and synchronize where inter-process communication happens. So that uses inter-process communication as said, mechanisms such as pipes, shared memory, or message queues. The parent may also wait for the child process to complete using system calls like wait or wait for signal object. Next one is we'll understand what is parent process. A parent process is a process that creates one or more child process during its execution. In operating system, this is done through system calls like fork, which is in Unix, and create process, which is in Unix. But we have chosen Windows environment for our execution and code implementation, and Windows. So in Windows, we use create create process. The parent process is responsible for initiating child process and often provides them with resource such as memory or data. So we'll know interprocess communication, which is very much crucial between the communication between parent process and child process for sorting. So interprocess communication in operating system refers to the mechanisms that allow process to communicate and synchronize with each other. This process could be running on the same machine or distributed across the network. So interprocess communication is essential for achieving coordination and data sharing between process in multitasking environment. So in this, the parent process will generate a large number of data and the child process will sort it and give the output. So this was about the theory part of our explanation. Next, we'll be moving on to this is the child process. So next thing will be continued by Rajshekar.
Hello everyone, myself Rajshekar. In Windows H, provide a Windows specific function like creating file mapping, creating process, etc. Studio.h provides the function for input output like printf and fprintf. stdlib.h provides utility functions like malloc, free and rand. String.h provides string manipulation function like memcpy and memset. Limits.h defines limits like int max for data type used in merging. Array size, total number of the element in the array. Children, number of child process. Child/array/size. Size of each subarray that will be processed by a child process.
So this was the explanation of header files, which was explained by Rajshekar. Now we'll understand what this code does. So this code implements a parallel sorting program in C for Windows, where a large array is divided into smaller chunks, each sorted by a separate child process. These sorted chunks are then merged into a final sorted array by the parent process. Okay. Next one, I'll be discussing from continuing from the void generate number. So void generate number, what it does, it generates random numbers, random integers. It generates random integers. So okay. Then there's a method called void merge arrays. Merges multiple sorted arrays into one. Next one is the main method, main execution of the code, that is variable, that is int I, which is an integer variable, and cmd args, command arguments. So are used for loops and command line arguments for child process. And next one is main array, stores the large array to be sorted, and hmap file. Hmap file and shared array used for creating and accessing shared memory. Next one is start info, structures for process creation and control. Result array stores the final sorted array, and child array pointers points to subarrays within the shared memory. This was about the declaration of the variables in our code. Next one is allocation of memory for the main array. So we have used malloc here, which is which is used to return the address of the address in the operating in data structures. So allocates memory for main array and checks for successful allocation. Okay, calls. If the memory allocation fails, then it will print that memory allocation failed for main array. Then it will return one. Then we have a method called generate random array, which generates an array of large size or random numbers. Next one is map file, which is shared memory setup using CreateFileMapping and MapViewOfFile. Okay, which shares the memory, which handles inter-process communication. Next one creates a share. The explanation for this is creates a shared memory object using CreateFileMapping. Invalid hand value indicates no physical file is used, and page read write allows read and write access. Then the array size is to declare the array of size, shared memory in bytes. Next one is Next, we have used if and else statement. If hmap is equal to null, then we'll print could not print file mapping object, and we'll get the last error where the error occurs. Then free main array and return one. Next one is map the shared memory for the parent process. So how it is done is, so we'll use the map file, which is for process communication, and startup and process information, structures, constructs, and command line arguments for each child process each child receives. Launch the child process with create process. Next one is waits for child process to complete 5 seconds timeout, closes handles to the process and its threads, which is the time quantum given for the execution. So next one is send printf. If command arguments of size of command arguments executes from this file path, then it would print creating child process with arguments of the file path, that is command arguments. Next one is debugging, printing the command line. So if print creating child process with arguments of %s, which declares the path, and print if fail to create child process so, and get the last error and return one. Waiting for all child process to complete. This is we'll put it in a loop. So for a 5 second timeout for waiting for all child process to complete. So okay. Allocates memory for the final sorted array, divides shared array into num children subarrays called merge arrays to merge the sorted subarrays into result array. That is with merge sorted arrays. In this part of the code, what it does is it will allocate memory for the final sorted array, divides shared array into num children subarrays, calls merge array method to sort subarrays into result array. Then is the printing of sorting complete. So this cleanup process is to clean up the memory and print sorting complete. Now generate a random number. Random number is generated again in a loop, which is declared by size and array, and we'll include the method void array, which will merge array, that will merge the generated numbers by the random array. So we will free the indices. This was the explanation of our parent code. So the execution of this is as shown below. So this is the output for our parent process. So what it does is could not open file mapping object. That is, it doesn't have the access for sharing memory between the parent and child process. After that, the last error, that is, we couldn't create the process, that is last error 2. That is also the reason for not getting shared memory between the parent and child process. Next one is child process is created with arguments of the file path of child process from 0 to 10 lakh, so on, up to 10 million numbers are generated by the generate number, and the printing statement is complete, that is sorting complete. The same thing is been shown here. Now let's move on to the child process. Move to the child part of the code, the child code, that is shown as here. So here also we have used the same libraries, the child code, which is shown here. So yes, so this is our child process, which has been named as child parent, which is nothing but child code. So here also there are some header libraries that is used for this code, and we have defined the array size, that is 10 lakhs. Now we'll be discussing function prototypes. Function prototype is nothing but there are two methods, that is sort array and one is compare. Sort array function that sorts a given array using quicksort, and compare method is used to compare functions using qsort. Next thing is the main function, that is int main, int argument command, and argument validation. So this is the entry point of the program. So the argument command, what it does is the number of command line arguments, though then the array of strings representing the arguments, check if the correct number of arguments is passed or not. Next one is what this line from 10 to 16. So ensures that program is run within exactly two arguments, starting index and size. If the argument is count is incorrect, it prints an error message and exits with code 1. Next one is parse the command line. So converts the string arguments to integers, and starting index will in the shared array assigned to the process, size number of elements in the subarray to process. Next one is accessing shared memory using and hmap file. Opening file mapping existing shared memory object created by the parent process. Okay, file map will allows read and write operation. So if it's false, do not inherit the handle. Shared memory, name of the shared memory object. So next one is map the shared memory into process addresser space. This is the operation. If this fails, prints an error and exits if the shared memory object is not found. Then mapping the shared memory. Maps the shared memory object into the child process virtual address space, allows the process directly access the shared memory as if it were a normal array. So max array size of it tells that maps enough space for the entire array. Okay. Next one is if shared array line 41 to 47. If shared array equals null, it will print could not map the file. If this fails, prints an error, closes the handle and exits. So getting the subarray is the next operation. Getting the subarray. Now for getting the subarray, int subarray equals shared array plus start index. This means calculates the starting point of the subarray within the shared memory. The child process operates on the part of the array of the part starting index. Next, sorting the subarray. Sorting the subarray is nothing but calls the sort array function to sort the assign the subarray. Next one is debugging the output. That is printing the first 10 sorted elements for debugging. So what it does is prints the start index and size for debugging, displays the first 10 elements of the sorted subarray for verification. Next one is cleaning up, which is to clean the memory. Unmap, close handle, hmap file. Then function to sort the array using quicksort. Uses the C standard library qsort function to sort the array, and the comparator function compare the use define the sorting order. Next. So from this code, we'll try to get the output for this. That is shown here. So as per the output, it tells the usage and the file path of child parent, start index, and size index. If it was failed to create, then it would have returned 1. So after this, so this is the output. Child process receives start index 0 to 1 lakh. First 10 sorted elements are 1 to 9. So this was the output for our code. Now from this, what we learn? Parent process relationship. What is parent process relationship? Creates a shared memory and fills it with data, spawns multiple child process to sort different chunks, coordinates and merges the result after the child finish. Next one is process flow summary. What is its summary? So parent process creates shared memory, writes the array and divides into chunks, spawns child process with start index and size. Child process maps the shared memory, accesses it assigned chunk using start index, sorts the chunk in small shared memory, cleans up resources. Then parent process waits for all children to finish, merge the sorted chunks for the final output. Now, conclusion part will be handled by Akash.
Thank you, Sachin. This program demonstrates the use of shared memory for inter-process communication in a multi-process sorting application. The parent process creates a shared memory object and divides a large array into smaller chunks. Then it swaps multiple child process, each responsible for storing a specific portion for array in parallel. The shared memory ensures that the process work on the same day without requiring costly data copying between processors. The child processes open the shared memory, map it into their address space, and sort their assigned subarray using efficient quicksort implementation. This approach leaves large shared memory to minimize inter-process communication overhead and achieve better performance. By distributing the sorting task, however, it requires careful resource management such as unmapping memory and closing handles to avoid leaks or conflicts. The program highlights the practical use of operating system concepts like shared memory, file mapping, and process. It also underscores the importance of model programming with clear separation of responsibilities between the parent and child responses. Such techniques are valuable in high performance computing and parallel processing applications. Thank you.
Thank you.